Hello YouTube, this is JBert1992 with your 7th C++ tutorial. In this video I will be talking about variables and why you should choose one over the other. So basically here I wrote out a shell program. You should understand what everything means. If you don't, please watch videos 4 and 5, part 1 and part 2 of building your first program, Hello World, and there I talk about every aspect and what exactly it means. Okay, so on a side note, the variables that we're going to talk about, I'm just going to write them in here kind of like a notepad. It's not going to be part of the program. I mean, these are aspects of C++, but this is not this isn't the syntax of them. So basically, we're going to start off with int, which is an integer, okay? int, you may recognize this because int main, int main. Integer is an integer. Basically, an integer is a whole number that is non-decimal. So 10, 20, 59, 86, them are all integers. 120, it's an integer because it does not contain a decimal. Well, so say you're averaging two numbers. So say we're averaging 10 plus 10 divided by 2, okay? Well, we know we're going to start off with, from what, kindergarten, second grade math, we learned how to average stuff, so we know 10 plus 10 is 20, divide that by 2 is 10, okay? That makes sense. 10 is an integer, that's what it spits out, okay? So now, what if we want a decimal? So we can use something called float. So as far as C++ is concerned, a decimal is considered, you can actually just call it a floating point is the same thing as a decimal point. A floating point, a float number. Okay, other compilers and other languages may use the term float, but they may declare it using a different name. But float is something that you can use. And what float is it, like I said, it's a floating point number. So basically, a floating point number can contain decimals. Well, so say you want to divide. Well, we want to average out 5 plus 10 divided by 2. Okay, well, we know 5 plus 10 is 15. Divide that by 2 is 7.5. Okay, it contains a decimal. It's a floating point. That's fine. So say you want to take this right here, 5 plus 10 divided by 2, and say you want to assign it to an integer. Okay, well, basically what happens is, as far as C++ goes, it'll let you get away with that. But the only downside is the 0.5 will be truncated. Since it's an integer, it only holds on to the whole number. It just leaves off, it truncates the decimal, and it's lost forever. You can't recall that. So basically, an integer, it's a whole number. Floating point contains a decimal. Now, a floating point is kind of like a smaller decimal. It'll be precise up to about 7 digits, okay? So we'll have 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, actually, 7 digits, didn't I say? Okay. So we're going to write number, and then we have 7 digits after, okay? So obviously, a floating point is going to be much longer than this because, so say like when you're doing pi, the more numbers that you have, the more accurate it is, okay? So this will be accurate if you're working with the tens, the hundreds, etc. It would be beneficial just to use a floating point, just if you're doing, you know, like 0.5. So say you're trying to calculate, you know, how much money is in your piggy bank, a floating point number is sufficient. Okay, but say you want something that's more precise. So say you are calculating pi and you want more precision, okay? So you can have double. Double is kind of like a big floating point number. Let me write that out. It's a big floating point number. And basically, a double is accurate to about 15 digits. Okay? Actually, that's a 0. Okay? So it's accurate to 15 digits, like I just said. Okay? So obviously, say floating point comes out to here, well, double is double that. It's double what a floating point is. For the most part, I mean, this one has 7 digits and this one has 15. That's about half. If you divide 15 by 2, you get 7 point blah, blah, blah. So it's pretty much half. So a double is kind of like a floating point. And if you want, typically doubles are more common. People just use them just to get that precision. I mean, the odds of us just dividing 5 plus 10 divided by 2 equals 7.5. That would be fine for a float, but typically we might be calculating like interest payments or stuff like that. So we have integer, which is a whole number, floating point, which is a decimal point or a floating point number that is accurate to 7 decimals, and double is accurate to 15 decimals. Okay, well, enough of that. So say we want to just have a letter, okay? Well, there's something called, people say char or char. Char, I'll just say char, I guess. It's a character. Basically, A would be a character, B character, C is a character. But since they are characters, you always want to separate, or you always want to tell C++ that it's a character by putting a single quote around it. It's kind of like in, I believe, my second tutorial, where if you have a string of characters, you put double quotes around it just to tell C++, hey, I'm doing a sentence, okay? Well, if you put the single quotes around it, it tells C++, hey, this is one letter, okay? So, okay, basically what happens with this char variable type is, I don't know if you've ever heard of the ASCII table. Basically, it assigns each letter a different number. So letter A might be 59, or I can't remember exactly what the numbers are, but I know that null is 0, and it just counts up from there, and each number has a different. So you can pretty much go to Google and just type in ASCII, like ASCII table, like that, and it'll give you a big chart. So what this does is it really stores the ASCII value, 50, 60, whatever, but as far as your concern is it stores one letter, okay? Only one letter. A char can only store one letter. An integer can store an integer that is up to, let me write it out for you before I try saying it. 47, 483, 647. Okay, and let me put some commas in here. Okay, so basically the range for an integer is 2.1 million positive, or actually that's billion, 2.1 billion, negative 2.1 billion to positive 2.1 billion, okay? Okay, now a floating point is, well, let me write negative to positive, that makes a little more sense. It is 3.4 times 10 to the 38. That's the range on floating points, and basically you need that much range to give you precise calculations to the 7th decimal place, okay? Well, a double is negative to positive 1.7 times 10 to the 308, okay? So that's 1.7, and then add 308 zeros, and then put your decimal place, okay? As you can see, that's significantly larger than 3.4, which has times 10 to the 38, which has 38 zeros after. This has 308 zeros after, okay? So you can see that's the range of the numbers. Like I said, char is only big enough for one, and the character has to come from the ASCII table. So, I mean, you can even have backslashes, you can have, percent signs. These are all examples of characters, okay? You can have numbers. You can actually have that is actually a character because that's on the ASCII table. Now, you wouldn't be able to write 5 plus, 6 like this because you can't add characters together. You want to use integers. But if you just want to display kind of like an address, you're never going to add someone's address together. You're not going to